All right, so kind of to summarize this idea of our quadratic function, right, y is equal to ax squared plus bx plus c. That parabola will open up, right, that parabola is what we will see. It will open up, be that smiley face, when your a value is greater than 0. When our a value is greater than 0, meaning, right, positive, we'll have a minimum value. When we have that frowny face, or when our parabola is opening down, our a is less than 0. We have a maximum, right? That highest point on that u versus that lowest point on the u. All right, so we're going to take a look at some of these examples of our functions, take out some coefficients, and then talk about whether that parabola opens up, down, whether we have a max value just by looking at the actual function and not the visual of it. So in our first example, we have y is equal to 5x squared minus 2x plus 50. Our a value is that number in front of the x squared. Our b value is whatever is in front of the x. And our c value is that constant that's being added or subtracted. So based off of this, right, we can determine whether that parabola opens up or down and then has a max or min value. So because this a value is positive, right, we have a positive 5, IVE, that parabola will open up, right, we'll have a smiley face, and then we'll have a minimum value. All right, same idea in this next one. We have y is equal to negative 100x squared plus 156. A value is whatever is in front of that x squared. So we have negative 100. B value is whatever is in front of the x. In this case, we have no x term. Technically, we have a 0x in there, so we don't include it. So B value is 0, and then C is at 150. So to determine whether that parabola opens up or down, we look to the sign of that a value. It is negative, so we have a frowny face, meaning it will open down. And then we have a max value, right? We have the highest point on that frowny face. All right, now that we are able to take out that a, b, and c value and determine whether the parabola opens up, down, and the max min value just by looking at the function, we're pretty much going to do the same thing but determine another of our vocab words, which is the axis of symmetry. And this axis of symmetry is that vertical line that we talked about, that dotted line that reflects the left-hand side to the right-hand side or vice versa. So again, it is that vertical line. That splits that graph. We're going to use a formula, right, to find out what x is equal to. We'll do the opposite of b over 2 times a. That will help us when we actually find our vertex, right, that x value comma y value. The x value of our vertex comes from that axis of symmetry. So whatever we get for that axis of symmetry, that's our x value of our vertex. And then we can find that y value once we plug it back into the function. So we plug in x into the function to find y. All right, so let's apply that formula, identify that axis of symmetry, vertex, and then maybe even if that parabola is opening up or down. All right, so looking at this first function, right, we have this lovely standard form. Let's take out that a, b, and c value just to identify what those values are. A is what's in front of the x squared, b is what's in front of the x, and then c is that constant. So there we go. Again, that axis of symmetry formula is x equals the opposite of b over 2a. So I'll start with that x equals, I'll do the opposite of b. b is 12, so I'm going to take the opposite of 12, meaning negative, and then over 2 times negative 2. And then simplify algebraically like I would. We get negative 12 over negative 4, which simplifies to 3. So that axis of symmetry is x is equal to 3. The vertex is that ordered pair, so I know the x value at the very, very least. To find the y value, I'm going to go back into the original function, right, that lovely function in standard form, and plug in my x value of 3. So y is equal to negative 2 times 3 squared plus 12 times 3 minus 7. Again, going back into that original function. And then I simplify. 3 squared is 9 times negative 2, negative 18. 12 times 3, 36 minus 7. And this whole thing simplifies to positive 11. So that vertex written as an ordered pair is 3, 11. All right, same idea with this next one. If you're feeling comfy, again, go ahead and try this on your own, identifying those values. Feel free to pause the video and then check your solution in about, like, I don't know, maybe 30, 40 seconds. So identifying those a, b's, and c values. A is what's ever in front of the x squared. B, we technically don't have an x value, so that's 0, and then c is that constant. To find that axis of symmetry, we plug it into our formula. X is equal to negative b over 2a. b is 0 over 2 times 3. Oh boy, 0 divided by any number is 0. So my axis of symmetry is x is equal to 0. Vertex is written as my axis of symmetry, comma, that y value, which I'll then plug back into my original function of y is equal to 3x squared plus 15. So y is equal to 3 times 0 to the second plus 15, which that simplifies to 0 plus 15. And there is my vertex of 0, 15. All right, so there are some basic key features of our graph, right? Identifying whether that parabola opens up or down, determined by that a value, talking about your x-intercepts, y-intercepts, symmetric point, talking about that maximum value, minimum value, and I understand that it's a lot, but we're going to do a lot of practice to make sure that we're reinforcing these skills. So great job today.